In Module 2, you'll also see binomial distributions, which is a different kind of probability distribution that's also discrete. Discrete means that the outcomes are countable. In Module 2, Lesson 2, it says this: 74% of adults in a certain country believe that life on other planets is plausible. You randomly select 5 adults and ask them whether they believe that life on other planets is plausible. The random variable represents the number of adults who believe that life on other planets is plausible. Find the mean, variance, and standard deviation of the binomial distribution for the random variable and interpret the results. So in this case, what makes this a binomial distribution is a binomial distribution has only one of 2 possible outcomes. So if I ask somebody, do you believe that life on another planet is plausible? They will answer yes or no. That's what makes this a probability distribution, along with the fact that there is a corresponding probability of success. In this case, success is defined as whether or not someone believes that there is plausible life on other planets. It says that 74% of adults in a certain country believe that life on other planets is plausible. That's the probability of success. We notate that with P for probability of success. We'll also need to know the probability of failure, which is going to be the other percent that takes up the 100%. So if 74% is the probability of success, the probability of failure would be 100% minus 74%, which would be 26% is the probability of failure. We'll use that later. All right, I think we're ready to get going. It says this: find the mean of the binomial distribution. The mean is the number of trials, or number of, in this case, individuals that you've asked, times the probability of success. So in this case, it's going to be 5 times 0.74. Remember, you always do probabilities as decimals when you're doing calculations. So 5 in my calculator here, 5 times 0.74 is 3.7. Next, they ask for the variance. The variance is the number of trials, or in this case, the number of people, times the probability of success, times the probability of failure. We'll notate the probability of failure with Q. So in this case, what we got? Number of people that we asked, that's 5 times probability of success was 0.74. Probability of failure, we learned that that was 100% minus 74%. That ended up being what? 26%, 0.26. So that was 5 times 0.74 times 0.26. And then in the calculator, that gives me 0.962. They want that to 2 decimal places, so 0.96. The standard deviation is the square root of the variance. So I'll take the square root of 0.962. And that gives me 0.980. 0.98. So here, let's see how they want us to round to 2 decimal places. Okay, on average, what, 3.7 out of 5 believe that life on other planets is plausible. In most sample of 5 adults, the number of adults who think life on other planets is plausible will differ from the mean, that's the standard deviation, by no more than 0.98, standard deviation. Sometimes with binomial distributions, they want you to find probabilities. And in this case with probabilities, you can use the probability calculator in Statcrunch. So let me show you where to find the probability calculator for a binomial distribution in Statcrunch. So we're going to go to Stat, Calculator, Binomial. And then we're going to put in the number of trials, the probability of success, and anything else we need. In this case, 30% of consumers prefer to purchase electronics online, and they randomly select 8. All right, so I think I can get that in the calculator. You randomly select 8. That's the number of trials. The probability of success was 30%. Prefer to buy online, and they want to know the probability that it equals 5, and that gives you the corresponding probability there. I can copy it and I can paste it in. They want you to round to 3 decimal places, so that 6 is going to round up to a 7. And then the probability that it's greater than 5, use the same calculator, just change your symbol. Greater than 5. Paste it in. Make sure it's to 3 decimal places. That looks good. Rounding's appropriate. How about less than or equal to 5? No problem. Less than or equal to 5. There's the probability. Got to get to 3 decimal places there, so that needs to round up to a 9. All right, and then you can create probability distributions by using that calculator and finding exact probabilities for each one. So put in N, put in P, and then put in probabilities for x equals 0, x equals 1, x equals 2, all the way down to x equals 6. All right, hope this video was helpful.